Hey everyone, how is it going? My name is Obaida. I'm a software engineer at Facebook or Meta, and today I will discuss about this algorithmic problem called alteration. And what does it mean is we'll be given an array of numbers, random numbers, and we need to arrange those numbers in that array such a way that the first element will be less than or equal to second element, but the second element will be greater than or equal to third element, and the third element will be less than or equal to fourth element, and so on. So that's why we are calling it the alterations problem, because it will go from low to high, high to low, low to high, high to low, and so on. So let's get it started. I will use this board, which I stole from my daughter, and I will use this board to explain this algorithm. Let's get it started. One naive approach would be we sort the arrays. So we take the lower half and we take the upper half, and then we just interleave the lower half with the upper half, and then we'll get this sawtooth type of graph. So let's see an example. For example, we have 1, 2, 3, 4, 5, 6, 7, and 8. So I have sorted the array, and if we take the first half and the second half and then we interleave, what I mean by interleave is we take those upper half and move it here, so that in every space between two numbers we get one number from here. So what does it mean? So we take 1 from here, and then we take 5 from here. We take 2 from here, and then we take 6 from here. We take 3 from here. We take 7 from here. We take 4 from here, and then we take 8 from here. So now it's like it's low value, then high value, then again low value, then high value, then again low value, then high value, low value, and high value. How is that? Because every time we're taking one number from our lower half, we are getting one low value, and then we are getting one value from our higher half, then we are getting the higher value. So it's always low to high, then high to low, low to high, high to low, like that. So this is one naive approach we can follow to solve this problem. But in that case, first of all, we need to sort this whole array. I have already sorted it, but it would be random at the beginning. And sorting, we know it takes order of n log n time. So can we do better? In order to do better than this n log n, we need to notice that this peak value here and this peak value, this is minima and this is maxima. Those minima and maxima are very localized. What does it mean? Localized means, let's say this value b, this is a local maxima, and it has to be greater than a and c. It doesn't have to be greater than d, f, e, or any other numbers. Same thing applies to value c. The c value has to be lower than b and d, and it has nothing to do with other numbers like a, e, f, or whatever it is. So what's the clue from here? The clue from here is, in order to get the local maxima and the local minima, we don't have to compare those values to each and every number of the array. We can just compare that value to its neighbor. So what does it mean is, whenever we're taking the value of c, we'll calculate if c is less than both b and d. If we find that c is less than both b and d, then c is in correct positions. Same things applies to the value d. If d is greater than to its neighbors, so its neighbors is c and e. If it is greater than c and e, then d is in correct positions. And how can we ensure that we have found the local maximum, local minima? So we'll go through those array and we'll check if we are satisfying the conditions. If we are satisfying the conditions, then the value is in right positions. If it's not, then probably we need to swap the value. So let's see an example. So here is an array of random numbers, 5, 2, 1, 4, 7, 0. This is completely random. There is no ordering among them. and we need to arrange this array such a way that it fulfills these conditions. So what does it mean is, so the first value will be less than or equal to second value will be greater than or equal to third value, and so on. So I have written down those conditions here, and here. So as we said earlier, instead of in order to find the local maxima and local minima, we need to compare each value with its neighbors. And if it satisfies the conditions, we don't have to do anything. If it doesn't satisfy the conditions, then we need to swap it. So let's get it started. So we compare each pair of values. First of all, we'll compare the first two values, 5 and 2. And the condition is 5 has to be less than or equal to 2. Does it satisfy the conditions? No, it doesn't, because 5 definitely greater than 2. So in that case, what we'll do, we'll just swap 5 and 2. So 2 will come here and 5 will come here. And the next thing is we need to compare 5 and 1. And the condition is 5 has to be greater than or equal to 1, which is true. So we don't have to swap anything. We can just get 1 here. And then we got 1 and 4. We need to compare if 1 is less than or equal to 4, which is true. So we'll just take 4. And then we have 4 and 7, and we'll compare if 4 is greater than or equal to 7, which is not true. So in that case, we need to swap 4 and 7. So 7 will come here, and then 4 will come here. So now you may say that why we are only comparing this value with this next value? Aren't we supposed to compare with the previous value as well? That's a very good question, but when we are comparing with this value with that value, and we are trying to find the local maxima or the local minima. So if we need to find the local minima and we are comparing it with the next one, we'll take the one which is lower than this one. So the local minima will even go lower. And whenever we're trying to get the maxima, the local maxima, and we're trying to compare this value with the next value, we're trying to find out which is bigger than these two, and then we're swapping this. So what does it mean is, if it's already greater than this, we are getting even a bigger value than this one. So these conditions, these left conditions, will always satisfy. So that's why we don't have to compare with a number with this left neighbor. It's just enough to compare this number with this right neighbor, and so on. So now we're here, and then the next condition is if 4 is less than or equal to 10, which is true, so we'll just take 10. So now let's see if we got our desired array. So if we plot it in a graph, I'm not going to absolutely put the values. I will just try to sketch something here. So first value is 2, and then it goes up 5, and then it goes down, which is 1, and then it goes 7, and then it goes down 4, and then it goes 10. So we got this sawtooth this structure, right? So from low value to high value, high value to low value, low value to high value, high value to low value, and so on. So that's how we can solve this problem in order of in time and without using any extra space. If you think this video is helpful, please do share with your friends, and if you have any questions, please write down your comment in the comment box below. I will try to answer your questions as much as I can. And if you haven't subscribed yet, please do subscribe. I'll see you in the next video. Thank you.